evening, YouTube. Ty, Metalhead Weatherman. I hope you guys are doing well. There is a lot to cover in this video because originally we were going to be covering the ice storm, but fortunately we also now have the slight risk being reinstated earlier today from the Storm Prediction Center across parts of the Midwest here. So we're going to cover both of them, but it's going to be a little bit of a skim through as we're getting closer to the event. We don't have to compare models as much, so this should be a shorter video, but don't be surprised if it ends up being long. So that being said, the warning has been given out, and let's get into things. Before we even really get into things, we're going to look at what we've dealt with over the last 72 hours. Really, a lot of the snow that's fallen over parts of Montana, Idaho, and Wyoming have really fallen over the last 48 hours, I would say. 24 to 48 hours, I'd say. Some of this snow has already been falling across areas like Washington, the mountainous regions of Washington, Oregon, so to speak, and even over towards the Rocky Mountains, just to the west of Denver. But watch how quickly watch how these totals don't really drop off, especially around these mountainous ranges here. This is the snow that's fallen just over the last 24 to 48 hours. This is where we're getting that grand total coming in from 72 hours is really from the 48-hour mark onward. And there's still snow that's not being reported at the time. There's actually snow still falling over these regions right now. And then now we're also starting to see some action across parts of Minnesota and Wisconsin where we could expect some ridiculous snowfall totals there. I go a little bit more in depth with that in yesterday's video. Link to that will be in the top right corner, so feel free to watch that. But that's not what this video is about today. We are going to be more so talking about the severe threat and talking about ice. So we'll jump to the severe threat because there's not a whole lot to talk about. We kind of know what the deal is for the most part. It's still mainly a linear type threat, but the area has changed quite drastically. Whereas before we were looking more so towards Arkansas, Louisiana, and parts of Texas. Now we've slipped this back so far to the west now. We have Oklahoma City, Norman involved in there, and pretty much all of central Oklahoma in that slight risk. We even now have Illinois over towards and Missouri in play here. We have Hannibal, Missouri in play, Kansas City. Actually, it's just outside of that, but Jefferson City is involved. So is St. Louis and Springfield. We'll be watching all across this region for an increased threat of severe weather, mainly going to be damaging winds as indicated by the 15% marker here. There is a 2% tornado threat in this region as well, and a 5% hail threat, given the fact that this is a little bit closer towards more of a cold core type setup. So that being said, let's go ahead and look at some of the parameters here, and we'll be able to kind of pick up really quick as to why we've gone back to that slight risk or have it being reinstated, where it's been, just exactly where it's located. So the main area I want you to avert your attention to is right around here, where you can kind of see this little area of swirl developing right here. This is where our low pressure is going to end up hanging around for a bit. And you can see where that cold air is swinging in on the backside, and this warm air is evecting out ahead of it. It's a classic cold core setup. And what's going to end up happening as we get into the afternoon, this warm sector is going to be a little bit stronger, and this is also going to be a key factor in our ice storm here. And these are the surface temperatures at the ground. We're going to go into the upper level temperatures when we start talking about the ice threat. But you can see right here, this little pocket develops here. And right along this pocket where the contrast is going to be, right in between there, that's where we're going to have all our action. This is where the storms are going to fire and be the most intense. This is mostly going to develop as a squall line, although prefrontal cells can't be ruled out, especially given the fact that we have a very abundant, very impressive wind field with this too, in all levels of the atmosphere, I would say even. So we will be watching for the threat of pretty much everything. But mostly I will look for a squall line and maybe even some word of a potential bow echo forming from this. Of course, this hasn't happened yet, so there's a lot of room for changes. But definitely seeing a trend to where a line of thunderstorms is definitely going to be developed is definitely seems like the most likely threat here. And we could get a little bit of everything out of that. So we've seen the warm sector. We look at the moist sector. We've talked about this a lot over the last couple of days. Just going to show it really quickly. With our severe weather threat, it's different from our cold or wintry weather type threat. You don't need impressive dew points like what you're seeing here in order to get a wintry type event, but severe weather you do. You need dew points around at least 55 or higher, I would say. It's usually a good point to start at. So that being said, dry line is right here, and then right up against that dry line where we got those 30 to 40 degree dew points, we have those 50, 60 degree dew points. Very rich atmosphere right here. And as we go on, we see that much drier air coming in behind it. Like I said, these contrast points are going to be exactly where we end up having significant weather. So that's what we have going with that. And then Thursday, the severe threat diminishes. It's going to be pretty muggy over towards the southeast, by the way. So anyone that's working outside like myself during the course of the day, make sure you have a little bit extra hydration with you. It's going to be notably different. That being said, let's go ahead and switch this over towards the mid-level to low-level jets. And this is really where things get kind of telling as far as the type of hazard we have. Very strong wind field here with this system. You can already kind of see it. Multiple pockets where we're getting up to 70, 80 knots. We've been seeing this for about a week straight now. So this is no surprise to us. Look at this streak that develops once we get to the afternoon hours, right across Missouri. We have a little pocket here where we're trying to get up to 80 knots even, and we end up doing so a little bit later in the day. So these storms are going to fire off, and then also I'm a little concerned for an increased threat of maybe some near blizzard conditions around where that low pressure ends up developing, especially over towards the Dakotas. So I'm keeping an eye on that. But not only is it going to be windy and cold for a lot of these regions across the north, we're also going to be dealing with a lot of wind. So wind chills will become a big factor. So make sure you are layered up in or out the house, really. Make sure your heaters are in good working order because you are going to be using them. I can almost guarantee you. But even as this storm system starts to shift towards more of a wintry threat, large area, even I could even say towards the UP, we might have to watch for some near blizzard conditions. There's a funny criteria behind that. It's more so based off of time duration more than anything else, but snowfall. But either way, with the snowfall that could be happening there, if we could get those winds to sustain long enough above, I think it was 35, 40 miles an hour. And it's also visibility, if I remember correctly, about less than a quarter mile. But that has to be sustained for 4 hours. The storm lingers for that long, we will have had a blizzard here. But that being said, I'm not too sold on that happening for that extended length of time. That's why I'm calling it near blizzard conditions. But that being said, still, it's not something you want to be out in. So don't be surprised if your authorities and officials discourage road travels. That being said, we're looking at the mid-levels of the atmosphere. Let's look a little bit closer to the ground where we are. How does that 80-knot jet streak translate a little bit closer to the ground? So we'll look at the low-level jet, and this is where a lot of our tornado juice will end up being in our severe threat region. And we do get a pretty sufficient area where we get up to about 50 knots plus. Always a red flag whenever you see that. So that lets you know a tornado threat does exist. Speed and directional shear are the things that you need for tornadic activity and supercells. Marginal severe is there, but the Cape value has always been an issue with this setup and continues to be so. But you do see this interesting curve in the hordeograph here. It's a little bit disorganized, but right at the surface, there's a really solid storm relative helicity here to keep an eye on. So with that, even though there aren't like a bunch of high quality matches in regards to supercell sounding analogs, the ones that we do see do have the tornado tag with them. So that's interesting. And then on top of that, this does have that classic supercellular look while almost looking like it's in a semi-discrete mode. So again, this is a tricky setup, but don't be surprised to see a couple of tornadoes out this. Not saying that it will happen, but this setup does kind of lend itself towards being a little bit of a sleeper here. So that's what we have going on there. Like I said before, the Cape is going to be one of the biggest limiting factors, especially towards the surface. The surface Cape is actually going to be the strongest part of this. If you look in the mix layer, it's just really unconducive to severe weather, so to speak. The other parameters are in enough abundance to kind of overcome that, especially with us being so close to that low. But look, as you can see here, so we had in the 19Z, there's one little pocket right here where we start to get above 1,000 joules per kilogram, which is just barely sufficient enough for a few severe storms. But look how quickly that fades away and we start to get into the 300, 400s. Just looks unideal for a severe weather environment for sure. But even then, with cold core setups, you don't really need a lot of Cape. The lift, the forcing, with the other dynamics in play, like I said before, often will overcome that. What kind of storm coverage we will get is still a little bit of a mystery, but we'll try and go over the storm mode tomorrow morning. That being said, let's now switch over to the ice storm threat. And this is a accumulation probability for freezing rain above 1/10 of an inch ice. Probability starts relatively low, and this is heading into Wednesday evening. But those probabilities are on the rise. We're already above 50% by this point. If we jump this another 12 hours, look at the difference that ends up occurring here. We're getting into the pinks where we're above 80%. And this is especially bad across southern Michigan here. We're going to be watching these guys really close. And then there's a secondary spot over here between Iowa part and the Wisconsin-Illinois line here, where we're getting moderate to high confidence there, where we're getting close to that 70% plus value, so to speak. Once we get to, I'd say, what was it, Wednesday or Thursday night? I'm starting to lose track of my dates here. Today's 21st. Okay, so this is Wednesday night. But Wednesday night, we can see the threats starting to shift further to the east. Look out New York City at this point, because now it's starting to shift over to you guys. And then by the morning, we have an increased threat, but it's not really as impressive as what we're going to be seeing down here. Still warrants attention, but the probability of you guys having a significant ice storm over here is much lower than what we're going to be seeing across the Great Lakes, especially across southern Michigan. With that being said, let's go ahead and look at things. We already got to look at what the surface temperatures could look like over that region. What we're doing now is we're going to go look at the mid levels of the atmosphere, just like we looked over towards the jet stream, but we're going to look at the temperatures. So here's what our 700 millibar temperatures look like. So just so you know, 700 millibars is about maybe close to 10,000 feet off the ground. You would think, okay, why is this relevant to me? Well, with ice storms, what ends up happening is well above our heads, the temperature's well below freezing, right? And at the surface, we have temperatures that were also below freezing, right? What ends up happening, though, once we get to this mid-level part of the atmosphere and towards the lower parts of the atmosphere, the temperatures end up starting to go just a little bit above freezing, not by much, but just enough to where we start to see a little bit of thawing happening here. So that snowflake that's heading into the middle part of the atmosphere, it begins to melt. It becomes a raindrop. But once we get toward the surface again, it either refreezes before hitting the ground or refreezes after it makes contact with the ground. And this is how we end up getting that ice accumulation or sleet. So what ends up happening here as we go forward, we see that warm air advect aloft, and look what ends up happening here. We're sitting right on that 0 degrees Celsius line, which is our freezing point. And if I go up a couple more scans, look what happens here. We're actually above freezing a few thousand feet above our heads. And this ends up persisting throughout a good portion of the day, but those surface temperatures do not make it above freezing. That being said, given the lighter moisture returns that I've been talking about here earlier, look what we end up seeing here. Because I can use the sounding analog, interestingly enough, for this. Okay, so here's a great example. Here is our 32 degree line. Here's our 32 degrees at the surface right here, right? So we're at 32 degrees, and then look what happens out here. When it gets cold, when the temperatures drop on these sounding analogs, they go to the left. When they increase, they go to the right. Look what happens here. See this little pocket right here where we're going to the right, and we're going above freezing now. This is just above our heads, a few thousand feet above our heads in the 850 region. And it stays above freezing for a good bit here until we get right between the 500 and 700 millibar range here, which is about 10 to 15,000 feet above our heads. With the freezing point being so low, this is going to freeze on contact. So we can actually go ahead and look at what the probable precipitation type is going to be, or the best guess at precip is going to be. They say it's going to be rain, but with it being 32 degrees at the surface, this is going to freeze because it's going to be cold here well before this starts here, well before this event gets going. So this is going to change over to freezing rain and then stay freezing rain for a while, which usually will lead to greater ice accumulation across this sector. So we continue to drag this forward, and it's not really until Thursday morning where we start to see the ice threat diminish just based off the temperatures. Then there's a secondary system that comes in, and that's going to bring in snow to put on top of that ice. So road conditions across this region are going to be hazardous. Now, I know these guys up north are a little bit more seasoned when it comes to winter weather driving, but even then, there's some things you just shouldn't do. And in this situation, with a quarter-inch of ice possible across that region or more, and then snow to go on top of that, it would just be best not to get out on the roads. We saw what happened in Texas, Arkansas, and pretty much across the South whenever an ice event hit. And it was a pretty significant one. We're seeing up to half an inch ice in multiple locations, some places even up to 3/4 of an inch. A lot of people the people that ended up passing away in that event were mostly people that were in accidents. So it's just a reminder that if you really don't have to go out, just don't do it. So that being said, we already have an idea of what the precip will look like here. We'll go over it one more time, but we already know what's going on here. We're going to just pretty much jump this ahead to about maybe 13 hours ahead from our current starting point. Here is where the ice starts to come into play. This is towards, I'd say, maybe 9-10 o'clock in the morning. It's where we start to see the first sleet and ice start to fall across the region. Now, there is a point where some parts of far southern Michigan could turn back over to rain, but as we get into the course of the evening, that cold air is going to start to drop back down, and a lot of what's already fallen is going to, if it does end up melting, will still refreeze, especially as we go on the backside of this other system here. And given the moisture content that's available a little bit further to the south, as this rain is trying to vect north, this could lead to some significant ice totals right across this region. There's two pockets that I'm concerned about as far as ice potential is concerned. It's this corridor right here, and then right across here, especially just a bit north of the Michigan, Ohio, Indiana lines. So that being said, let's go ahead and look at the ice totals here. So we'll start out with the Euro. I'm going to tell you right now, all the global models have this a little bit overdone in my opinion, but it isn't completely out of the question given the moisture content that we have available. But to see an inch over this region right here, that would be a devastating ice storm. But why I think this ends up being overplayed is because look at the totals across this part of the Northeast. This system's going to be moving a little faster at this point, and a lot of this is going to turn over to rain too. So I don't think these values are going to end up coming to fruition. If we look at the Canadian, it's a pretty similar deal. We can see quarter inch and an inch and a quarter in some of these regions. It's a little bit overdone in my opinion, to say the least. GFS has been really interesting with this one. This one has the furthest trend to the south still. It's been holding true to that from the get-go. It'll be interesting to see if the GFS, the lone soldier that's held up, will end up being the one that wins out here. I'm kind of leaning a little bit towards no, given how far north the warmth ends up getting, the warmer air starts to push, because we've been seeing originally that Ohio Valley was going to end up seeing ice, and then this has been slowly trending more and more to the north. When we look at the traditional NAM, very aggressive too. A small pocket over here where we could see up to an inch of ice. It's alarming to see that this many models have that potential there, but the global models at this point can sometimes be a little bit wacky. One thing I will note though is that we do end up seeing the 3 kilometer NAM getting up to that half inch of ice, which would be absolutely devastating. But this is more realistic. The amount of moisture that you would need to get an inch of ice is absolutely ridiculous. And the thing with these kinds of systems, cold air usually ends up lagging too far behind the moisture to end up producing something like this. Especially with a setup like this where we end up seeing two systems coming in one right behind the other. They're pushing each other forward. So what ends up happening more often than not is this system will move in too quickly and often end up lessening these totals. But the fact that we're seeing a net group of global models and regional models heading into that 1 inch plus territory tells me that there is significant ice possible for sure. Now here's the model that I like to look at the most, and I think this is the most fair comparison. And even then, this still has up to half inch ice possible in some sections of southern Michigan here. Over towards the Illinois, Wisconsin line, we're still possibly able to see up to about 0.4 of an inch there. And then even over towards Iowa, we can see at least 1/10 of an inch or more across this region. I don't care how good of a driver you are in the winter weather, you still don't want to drive on 1/4 to half inch ice. We'll still have to watch the northeast as time goes on, because we are seeing 1/10 of an inch plus, which will still cause problems on the road. But of course, it won't be half as devastating as a 1/4 inch of ice, because then we start to get into power outage issues, and then a half inch ice, we can start to even see some trees getting weighed down and maybe even falling. So dangerous weather ahead for a lot of folks this week, especially as we get into the midweek here. I'm going to do my best to keep tracking this as best as I can and keeping you guys ahead on the other stuff to come. There is a day 6 slight risk already issued for this weekend, and I'm going to do my best to cover that. I think that'll probably be a video, I don't know, maybe Thursday or Friday, depending on what this system that we're dealing with now ends up doing. So, yeah, a lot to keep track of, a lot of content coming your way. Hope you guys have been enjoying it. If so, you know what to do. Do I really even need to say it? But that being said, I'm going to try to make a video in the morning for the severe threat. Till then, this has been Tyler Metalhead Weatherman. I'll see you guys in the next one. Take care and have a good night.